Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Two Things Can Be True by Michael Lefkowitz. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Each clue read left to right or top to bottom obeys two of the following rules. So that's why two things can be true. It doesn't obey three things. Or maybe it does. I don't know. It has to obey two at least. What are the rules? We have x sums, where the clue is the sum of the first x digits in its row or column seen from the direction of the clue, where x is the first digit seen. So, for example, if this were, say, a 3 here, x would be 3, and therefore, if this was an x sum, if this clue obeyed the x sum rule, that would mean the first 3 digits of the column in that direction must sum to 12, right? Because x is 3, and the first 3 digits, x digits, seen in the column or row must sum to the clue outside the grid. And that's an example of how x sums work. We also have sandwiches, where the clue is the sum of the digits between 1 or 9 in its row or column. So, for example, if this were a sandwich clue, that means between the 1 and the 9, there would have to be digits summing up to 12. So you could have 5 and 7 here, and this would be valid. Because between the 1 and 9, you have 5 and 7, which add up to 12, which satisfy the sandwich part, if this were a sandwich clue. And that's an example of how sandwiches work. And we have neighbors, where the clue is a pair of given digits to be placed next to each other in the row or the column in the orientation shown. So, for example, if this were to be a neighbor's clue, that means 1 would have to appear somewhere first, and then it would have to be directly next to 2 in this column. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the one that stands out to me is the 1-1 clue in row 9. 1-1 cannot be neighbors because they are in the same row, and you can't have duplicates in the same row. You have to have the digits 1 through 9 once each exactly. So therefore, it must be an x sums, and it must be a sandwich. So that means between the 1 and 9, there has to be 11. The first x digits must add up to 11, and it cannot be 1. It could be 2, or it could be 3. It cannot be 4, because 4 cannot add up with 3 other unique digits to add up to 11, right? If you have 4 unique digits adding up to 11, it's 1, 2, 3, and 5. So that doesn't work. So this is 2 or 3 here. If this is 2, this has to be 9. If it's 3 here, it could be 3, 1, 8. Hmm. Huh. So if you have 2, you have 9 here, and then you cannot have 3 digits adding up to 1. So you would have to have 9 and 1 here. So if this were 2, you'd have to have 9 there to add up to 11 for the x sum. Is there a way we can color this? Maybe not. We're gonna mark x sums. X sums will mark as green, and sandwiches will mark as pink, and then neighbors will be orange. So this has to be match both x sums and neighbors. So this is green and pink. It cannot be neighbors. So if we were to have a 2 here, that would guarantee this is 9. You cannot have 3 digits adding up to 11. If you don't, because 1 has to be not between the sandwich. And we can't have 2. So therefore, what would be left is 3, 4, 5 if you have 3 digits, and that adds up to 12. So it must be 2 digits here, and then this would have to be a 1. So then this would have to add up to 12, and you'd have to have 12 between these 3. You would have 2 digits and 9. So that seems okay. You can't have 2... Oh, wait, hold up. To add up to 12 for the x, so this would not be neighbors because you have to have 1 and 2 in that order. So it would have to be... You can't have 2 digits adding up to 12. It would have to be... It would have to be 3 digits. So this would be a 3. You can't have 4 digits adding up to 12 without a 1. So this would be 3. It would have to be 3, 4, and... It could be 3, 4, 5. Okay, 3, 2, 7, adding up to 12. 4, 5, or 2, 7. This would have to be... Cannot be 3 digits adding up to... 9. So... Because we don't have a 3 available. And you can't have 2, 4, 6 because one of these has to be 2, 4, 2, 7, or 4, 5 to add up to 12 with a 3. So this would have to be 2 digits adding up to 12. It cannot be 5, 7 because that would eliminate 5, 7 here. It would have to be 4, 8, I believe. So this would be 4, 8, and 9 there to add up to 12 in between the 1 and 9 because, again, cannot be 3 digits. Can't be 4 digits, obviously, because 1 cannot be in the sandwich. So that would eliminate 4 and 5 here. This is 2 and 7. So far, this is all kosher. This can't be 5, so that 4, that would make that 6, and this is 5. This satisfies that. Interesting. So this looks like it could potentially be a correct path. What happens if this is 3? If this is 3, then this can't be neighbors here. So it must be 34 to add up. It cannot be 5 digits because if it's 5 digits, that would be too large. Sorry, 5 digits could not only add up to 35. That would be, so can it add up to 34. So this would have to be 6 or 7 digits here, if that's the case. If this is 3, then this is either 1, 8. It cannot be 1 and then 8, but it could be 8 then 1. Because if it were 1 and 8 here, then the sandwich would have to satisfy that, and it could only be 8 and 3 between the sandwich, because you can't have 8, 2, 1 between the sandwich. So you could have 1 and 8 here. 2 and 7 work. Hold up, that's 12. It would be 1 and 7. So that could be actually 1 and 7. So 1 and 7, 2 and 6. And those are the possibilities, if that's the case. So that does kind of work. So let's go down this path. What happens if it's here? If it's 6 or 7... if it's 7, so what happens if it's 7 here? If it's 7, that means the first 7 digits add up to 34, so the last 2 must add up to 45 minus 34, which is 11. So this would be 8. And we'd guaranteed have a 1, 9 somewhere here. But that doesn't work, because we do not have 34 in between them. Oh. Yeah, this just can't work. 34 in between the sandwich. So the most you can have in between a sandwich is 35. But to have 34 in between a sandwich does not work. Because you'd have to be missing 1, but we already have 1 outside of the sandwich, outside of the digits inside the sandwich. So therefore, this cannot be a sandwich. This has to be, because, yeah. So that's the reason why. So this has to be X sum, which is green, and neighbors, which is, so this cannot be 3 here, so this must be 2. So that's the reason why we have that. So this is 2, which to add up to X sums must be 9 here. This cannot be 3 digits to add up to 11 between the 1 and the 9, because we don't have 2 anymore, and 1 was never available to be in between the 1 and 9. So this has to be 1 here. So this is guaranteed to be 1. So we're going to mark the crust of the sandwiches as red. So this is 1. Again, this cannot be neighbors, because of the 2 cannot be beyond that. So then this must be green and pink. Again, you can't have 2, you can't have 4, so this must be a 3 here. So this is 3, this must be 2 and 7. We have to have 9 here. So yeah, this is the same thing. This cannot be 3, 9, it cannot be 4, 5, 7, it has to be 4, 8. Which makes this 2, 7 here to add up to 12. And this becomes 5 and 6, so this is 6, and this is 5. We have a 9 here. There's only 3 digits that can be between the 9 and the 1 possible, so this cannot be a sandwich. So this has to be X sum and neighbors. So this is X sums, which is 6 or 7 again. If we had 7 here, the problem is these 2 digits would have to add up to 45 minus 34, which is 11, but we already have the 9 here to add up to 11 there. And these must add up to 11, so it's either 3, 8, 4, 7, or 5, 6. This can't be 4, 8, so this can't be 3 or 7 correspondingly. So this must be then 6 here. So the first 6 digits add up to 34, because if we had the first 7, these would have to add up to 11, and we already have the 9 here, and there's the 4, that doesn't work. So these 3 add up to 11. So this is 2, so these must add up to 9. So we have either 1, 8, 3, 6, or 4, 5. Cannot be 3, 6 because of 3, 6 in the column. 4 cannot be here because if 4 is there, that would mean You can't have 3 and 4 in order. This cannot be 3, though. So if this was 4, you'd have 3 here and 4 here, guaranteed to have for the neighbors. But then you'd have 3 and 1 here, but 3 and 1 and another digit never adds up to 31. So this cannot be 3, therefore this becomes a 1-8 pair, which eliminates 8 in the rest of the box. This can't be 3 then, either, to add up to 11. So this is 1-8 here. Which means the remaining digits in the box, or the column, are 3, 4, 5, 6, 7, 9. No 6. 3, 4, 5, 7, 9. Obviously, none of these can be 5 because of 5 in the row. This can't be 9 because of 9 in the row. To add up to 31, 3 and 4 digits never add up to 31. So this has to be 7 then. So this is 7, which eliminates 7 in the rest of the column. 3, 4, 5 adds up to 12. 6, 7, 9 adds up to 22. 22 plus 12 is 34. The first 7 digits add up to 31, which means the remaining 2 digits add up to 45 minus 31, which is 14. And you can't have 5, 9, so this has to be a 6, 8 pair. So 5 is here, 5 is here. Where's 5 in row 6? It has to be here. That leaves the remaining digits as 1 through 4. But this can't be 1 or 3. It's 2 or 4 because 3 has to be next to 1 in that order. So it could be 3, 1 here or 3, 1 here. So this is 1 or 3 guaranteed. That means we can have 2, 4 in the remaining digits. So this is 1, 2, 4. What else do we have? 12. Hmm. 32. Hmm. 14. This can never be 4. If this is 4, that would force this to be 3, 1, and that would eliminate 2 of the possibilities of the 3 possible digits there, and therefore both of the digits would have to be the same. So this cannot be 4, which means we guaranteed to have a 4 in one of these 2 cells. That's interesting. Three has to be one of these 2 cells. That's the reason why. So this eliminates 3 in the rest of the box. So this is 4, 9 pair, which eliminates 4, 9 in the rest of the column. So this is a 3, 5 pair. Interesting. 6 can't be here. So this is, again, it's X sums and its neighbors. To add up to 32 between the sandwich, that means 3 has to be outside the sandwich. Can you have... You cannot have sandwiches, then, and neighbors work. Right? If you had a sandwich and a neighbor here, the 3 would have to be outside the 1 and 9. The 2 would have to be inside the 1 and 9. And you could not have 3 next to 2 then, in that order. So that means we are guaranteed this has to have an X sum. That's very clever. So this has to be an X sum. To add up to 32... Oh, this could have been 5. Oh, no, but 5's in the box. That's the reason why. You can't have 4 digits adding up to 32, so it could be 5. Oops. It's 5, 6, or 7 here. Adding up to 32. And that would necessarily mean that this could not have a sandwich then, with 32 in between. Because 5, 6, or 7 would necessarily have to be outside of the sandwich because of the X sum. So this has to be X sums and neighbors. Huh. So 3 cannot be here, because if that were 3, it would have... Oh, I guess it could be 2, 3. Never mind. It's 2 and 3 in that order. What else do we have? Okay, remaining digits in box 7. We have 3, 4, 5, 6, 7. No 5 here, obviously. Remaining digits in box 4. We have 1, 2. No 4, no 5, 6, no 7, or 8. 6 cannot be here because there's 6 in the row. Seems fine. Remaining digits of box 1. We have 1, 2, 4, 7, 8, 9. No 9 in any of these spots. This cannot be 2, because if there were 2, 3 would have to be right after, and it can't be. 32. So if you had 5 here, that means 4 remaining digits would have to add up to 13. Hmm. Remaining digits in box 6. We have 1, 2, 3, 4, 7, 9. That seems fine. If this were 5, that would necessarily mean this is 3 and 2. So we have 5 outside. We would need another 13 minus 5, which is 8 outside, and we don't have 3 and 2, so it would have to be 1 and 7. And that would necessarily be problematic, because then this would have to be 1, 7. We'd have a 2 here, and this could not be 2 or 7 then. So that would eliminate all possibilities for that cell. So this cannot be 5. If this were 7, so what happens if this is 7? If this is 7, that becomes 2. This must have a 3 next to it, so then this would be 5. This must add up to 13, so this could be 5 and 8. So that does kind of work. First 7 digits, we have 2 and 3. Oh, can't have 3 there. Never mind. So, oh yeah, so this can't be 2. Because if this is 2, that would force a 3 to be here, and we have a 3 in the box. So this can't be 2. This is 7, that's 2, which eliminates 7 here, so it's 6. So these cannot be 2 here. This cannot be 7 here. So the first 6 digits add up to 32, which means these 3 digits add up to 13. Can we have 2 and 3 here is the question. Yes, 2, 3, and 8 could work there. So this is 6, which eliminates 6 here. So this is 8, which makes that 6. So we have 13 already here. 2 cannot be either of these. So either this is 2 and 3 or this is 2 and 3. Can we have 2 and 3 here is another question. Probably not, would be my guess, right? 2 and 3 here. So if we had 2 and 3 here, that would necessarily mean this is 5. So these 2 digits would have to add up to 13, which is 45 minus 32, minus 5, which is 8. And we don't have 2 and 3 available. We don't have 7 available. That's not possible. So this cannot be 2 and 3 here. 2 and 3, obviously, 3 can never be here. And this cannot be 3, so this must then be 3 and 2 here. This is 5. Therefore, these 6 add up to 32. 45 minus 32 is again 13. 13 minus 3 and 2, which is 5, is 8. So this is 8 here. That eliminates 8 and 2 in the rest of box 1. This can't be 2. 8 eliminates 8 in these columns here. This is a 1, 2, 3 triplet, which eliminates 1, 2, 3 in the rest of the box. So this has to be 8 here, and this must be 6 here, which eliminates 6 in the rest of the column. And this 2 eliminates 2 here, so this must be 3 and 1, which makes that 2. Therefore, that makes this a 2, 4 pair here. For the neighbors, this is 3 and 1, so that's satisfied there. This is satisfied there. That's 2 and 3. Remaining digits of row 3 are 1, 4, 5, and 9. And this cannot be 5 because of 5 in the column. And that's all we know. This 1 eliminates 1 in the rest of the column. This 3 eliminates 3 in the rest of the column. So this is 4, 5, which must add up with 6 or 7 to add up to 11. 8 cannot be... Okay, remaining digits of row 9. We have 3, 4, 5, 6, 7, 8. This cannot be 4, 8 because of 4, 8 pair in the box. No 5, no 6, no 6 or 8 here because of 6 or 8s in the columns, or 5 in the column. 2 eliminates 2 from being here. If this were a 9, remaining digits of box 5. 1, 3, 7, 8. 8 cannot be here or here. So 8 is one of these two. Can this X sum work? 7 doesn't add up to 14, because 7 unique digits must add up to 28. 1, 2, 3, 4, 5, 6, 7 at minimum. Obviously, 9 doesn't work. 4... Well, 3 unique digits doesn't work. 3... Oh, wait, could work. 3, 4, and 7. 1 digit doesn't work, obviously. So if it's 3, it's 3, 4, and 7. If it's 4, 4 doesn't work. Because we have 2, 5, and 6 already not in that set. So 4 would have to be at minimum 1, 3, 4, and 7. And that adds up to 15. So if it's an X sum, it's 3, 4, and 7. And you could have 4 and then 1 there. So it's either 14. Can you have 14 within a sandwich is another question, right? Okay. So if it's a sandwich, it's 3, 4, and 7. Sorry, if it's X sum, it's 3, 4, and 7. Can that work though? If you have X sum, it's 3, 4, and 7. Can it be? It can be with neighbors if you have the 4 here. So you could have 4 and then 1 in that order. This would necessarily be 9. What about sandwiches? So 3, 4, 7. That would force this to be 9. And could this add up to 14 in between? And the answer is no, right? If you have a 1 here, this only has 7 in between. If this is 1, this would have to be 5, 2, 8, and 6, which definitely 6 and 8 by themselves add up to 14. So if it's X sums, it must be with neighbors. If it's not X sums, obviously it has to be sandwiches and neighbors. So this, no matter what, has to have neighbors. So it must be 4 then 1, so this cannot be 4. This is 9 then, which makes this 4. It has to be 4 then 1. 1 can't be here. So because of that, this doesn't work as a sandwich ever. This is too large. 5, 2, 3, and 6. 5, 2, and 6 already add up to 13. Plus 3 is 16, and that's too large for the sandwich. So this must be X sums and neighbors. So then this must be 3, 4, 7. So this is 3, 7, and 4, which makes this 1. And this can't be 3 or 7, it's 8. So no 1 here. This can't be 3, 4, 7. No 3, 4, 7. This is 1, 2, or 9. So this is a 1. This is a 1. So that's the neighbor there. That's the neighbor there. This is the neighbor here. We have 3, 4 as a neighbor. Oh, I forgot about that neighbor. Okay. This had to be 3, 4 anyways. Oops. Anyways. Yeah. Interesting. I got to that anyways, in that sense, because of just deriving this part. But I think I made that a lot harder than I had to. 18 or 12. So we don't have any information here. If it's 12 as an X sum, it cannot be 3. It cannot be 5, obviously. So this would be 4. So you'd have to have 4, 8, 4. This would then be 1 and 8. And that doesn't work. Because X sum of 4 digits adding up to 12 must necessarily include a 1. And we don't have the 1 available. So this cannot be X sum. It has to be sandwiches and neighbors. Interesting. So 2 has to be next to 1, so this cannot be 1. This is 8, which makes this 1. Which makes this 4, which makes that 8. 1 has to be next to 2. So 2 has to be outside. So 1 has to be one of these. And 2 has to be one of these two. Interesting. Since 1 is one of these two, it can't be 1, 2, and 9 to add up in between the sandwiches. So it has to be 1 and 9, and then it has to add up to 12 in between. If this is 1, this would then have to be 9. So 4 eliminates 4 here. So if we had a 1 here, it would guarantee a 9 here, but this would have to add up to 12, so this cannot be 1. Therefore, this is 1, this is 2, which eliminates 2 here and 1 here. So this is guaranteed to be a crust. And a 9 cannot be either of these, so 9 has to be here. So this is 9. These 3 digits must add up to 12, so it must be 3 and 5. That eliminates 3 and 5 in the rest of the row. So this is 7. This is 6. This can't be 6 or 7. It's 4. This can't be 4. So this is 5. No 4, 5, or 7. It's 3. 5 plus 6 add up to 11. So we cannot have 5 and 6 in the rest of the row. So this becomes 3, 4, 7, 8. So we have 2, 1 there as the neighbors. This could be 1 and 8. Okay. 3, 7 as a pair. Remaining digits in this 3. Okay, 3, 7 as a pair eliminates 3 and 7 in the rest of the column. This can't be 3. It's 5, which eliminates 5 here, so it's 3. That means none of these can be 3. So we have a 4, 7, 8 triplet, which eliminates 4, 7, and 8 in the rest of the row. So this can't be 7. This is 3 here, which makes this 7, which makes that 3. 5 here eliminates 5 in the rest of the row, or the rest of the column. So this can't be 5. This 4 eliminates 4 in the rest of the column. That leaves this as a 2, 7 pair. 7 cannot be here because of 7 in the column. So this is 2, which makes this 7. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here. So this becomes a 1, and this 1 eliminates 1 here. So this is 9, which makes this 1. No 1 here. No 9 here. No 1 or 9 here. It's 4, 5. 7 eliminates 7 in the rest of the column. No 4 here because of 4 in the column. We have 1, 4, 5 remaining in column 4. This can't be 5 because of 5 in the row. We have 6 and 8 remaining in column 6. This can't be 6 because of 6 in the row, so this is 8. That's 6. 1 eliminates 1 here, so we have a 2, 9 pair, which eliminates 2 and 9 here. So this is 1. We have 5, 6, and 9 remaining in row 7. This can't be 6 here, so this must be 6 here. So this is 5, 9 as a pair. Remaining digits of column 7 are 2, 7, 8, 9. No 2 here. No 8 here because of 2 and 8s in the rows. Remaining digits of column 9 are 4, 5, 7, 9. This can't be 5 because of 5 in the row. And remaining digits here. Where is the 3? In box 3. It cannot be here or here. It has to be here. So this is 3. Remaining digits in the cell. We cannot have 1. It could be 2. Whoops. It could be 2, no 3, 4, 5, no 6, no 7, no 8, or 9. So we have a 2, 4, 5, 8, and 9 quadruplet in column 8, which eliminates 2, 4, 5, 8, 9 in the rest of the column. So this is 8, which makes this 7, which makes this 4. 7 eliminates 7 in the rest of the column. So these can't be 7. We have a 2, 9 pair now in column 7, which eliminates 2, 9 in the rest of the column. So this can't be 9. This is 8. Okay, 4 eliminates 4 in the rest of the column here. 1 and 8 are next to each other. So that satisfies the neighbors. We could have 9 here, and that would be 5, 6, 7, which works as a sandwich. If you have 9 here, then this must be an X sum. Okay, so this definitely satisfies neighbors. Can it be an X sum is the question. 5 digits don't add up to 18 without a 1. 2 obviously doesn't work as an X sum. 4. 4, 3, and 5 add up to 12. But 12 plus 2 doesn't work. It adds up to 14. 12 plus 9 doesn't work. It adds up to 21. So this cannot be an X sum, therefore it must be a sandwich. Which means 9 has to be in between the 1 and 9. So this is 9, which makes this 2, which makes this 9. That leaves this as 7, 5, and 2. That means this can't be 5, it's 4. This 9 makes this 5, which makes this 9. 4 eliminates 4 here, so it's 5. This 7 eliminates 7 here, so it's 1 and 7. 9 eliminates 9 here, so it's 4 and 9. This can't be 4, 5, it's 1, which forces this to be 4. And that's a solution. Very cool, actually. I like the idea of that you can satisfy 2 out of 3, and then you have to figure those out. I didn't completely finish some of these, which would have made things easier if I had done that. But either way, still a pretty cool concept. It does sort of lead you down the path where you have to go, but I mean, that's what a lot of these puzzles are like, so. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.